Okay, welcome back, everybody. We're going to start with the next session. Our presenter is Dawn Bedard. Dawn works for Microsoft. She's an architect within the Network Services Group. She focuses on address management, DNS, and IPv6. Dawn has more than 20 years of experience in consulting companies, supporting companies with address management, again, IPv6, IPv4, and DNS technologies. She also worked for different government agencies. Dawn, welcome.
Can you hear me? Am I on? All right, cool. So, as he said, I now work for Microsoft. Forward. Ha, there we go. Here I am. So I work for Microsoft. I've been with Microsoft for about a year. I came from the government side where, as most of you know, with the OMB mandates, we've been implementing IPv6 for many years. A lot of the experiences and a lot of the best practices that have come out from government side, like DREN. They're a fabulous organization. So I came to Microsoft, and part of what I was brought in to do is to work on the IPv6 environment. And like many organizations, whether you're small or large like Microsoft, there are a lot of challenges in getting IPv6 enabled in the environment. So what I want to talk about is where Microsoft started from an IPv6 perspective, some of the challenges that we ran into and that I found as I started getting into this, what we learned, how we've improved, and where we're going. And then I want to talk a little bit about Microsoft clients in an IPv6 environment. Just a couple things to give you a little FYI. Here's how it works. This is why it works. And then we'll take some questions at the end. So let's take a stroll down memory lane, right? We go back to 2011 and we had IPv6 Day. The goal of IPv6 Day was to stand up a website for 24 hours and get everybody motivated in IPv6, right? If you remember, Aaron, there's a big spike in IPv6 interest in 2011. There was a lot of popularity. Everybody got excited. Corporate-wide, I don't care if you were small or if you were large, IPv6 was on everybody's buzzword list, right? If you think about it, Microsoft was actually one of the leading proponents with IPv6 because they have supported an IPv6 stack since Vista. And for those of you, Vista came out officially in 2007. So that was a really long time that you could get a Microsoft platform that supported dual stack. So about a year later, we had IPv6 launch. IPv6 launch, the goal of IPv6 launch was now that you have this experience standing up a website, why don't you stand it up, keep it going, and everybody can dive into getting IPv6 going on all of the networks. Again, 2012, there was still a lot of interest in IPv6. So what did we learn from those two events? Well, we learned a lot about the fact that you have to have an infrastructure that can support IPv6. You're not just going to turn it on over a weekend. You have to look at the equipment that you have. You have to look at the networks. You have to look at your servers, your OSs, your applications. This is a big picture. And if you're going to do it, you need to start planning for it. Part of planning for it is trying to figure out how are you going to track all these addresses. If you think that you can track IPv6 addresses with a spreadsheet, you're going to get really cross-eyed really fast, right? Okay? So tracking your IPv6 addresses is important. And there's a lot of ways to do it. You've got a couple of vendors here that can talk to you about it. But there's a large market for IPAM vendors. But it's important you figure out how are we tracking our IPv6 space. The next thing that we learned about is that it's going to take us a while to get there. Again, you're not going to turn IPv6 on in a weekend. You're talking years of planning to get IPv6 enabled because there is so much to it. You're talking every nook and cranny of an organization to get IPv6 going. And lastly, you have to work together. So in an organization like Microsoft, we have different sides of the organization. We have our enterprise side. When I go into the office and I sit down and plug in my laptop, That's our enterprise side. Just like everybody else, they have to make it work when I want to print. I want to print. Then we have our cloud side. We have our other businesses. Everybody has to work together. If you as an organization have these little silos within yourself that are trying to do their own deployments of IPv6, you're going to run into problems because nobody talks. So now we go forward 4 years. And we think about, okay, what did we run into? Well, one of the first things that I have to admit to is our addressing plan really wasn't the best. And you heard several conversations and presentations yesterday talking about the importance of planning your address space. How do you want to plan it? Again, it's not something you're going to whip out in a week. And I'll talk more about the IPv6 plan, but let's just get to the point of saying, yeah, our plan had a little problem. What was written on paper and what was developed in like a week of somebody going, well, I think this is what we should do, didn't take into account all the things that it should when you're planning your addressing plan. So we had a challenge in that area. The other area that we had a big challenge was an overall master plan. And again, this is something that I think is really important that everybody should think about is when you want to implement IPv6 in your organization, you need to plan it as a whole. You need to have a grand master plan. And everybody needs to work to that plan. If you don't have a grand master plan and somebody helping to organize this grand master plan, you're going to run into troubles. Because again, what was implemented where and how? It got deployed on all the servers down here, but you know what? The tier 3 network up here doesn't support it. Or it supports it in this center, but not over in this center. And you get chaotic. And now you have no idea what you have, and you have no idea where it is. The other thing that you have to think about, and this is a recurring theme that you're going to hear, everybody has to work together. Everybody has to collaborate and talk. And we had challenges in that area. Again, we had some groups implementing it one way, we had other groups implementing it another way. And the prioritization was different. The other part of this to really, think about is that did IPv6 Day really make a difference in our customers' needs? So we as Microsoft, there was a big spike, a lot of interest 2011, 2012, but in the grand scheme of things, was there really, did it really make a difference? And what I found was one of the biggest issues that we had really came down to this business versus technology. And this is a battle that, from an IT perspective, you're constantly battling, right? IT says we have to implement this technology, and business is saying, why? There is no justification. What is your business justification for implementing this? And everybody has to take a step back and look at it. And we danced around this yesterday. You have so much money, you have so many resources, and you have demand. Customers saying, I want these features. Every application developer has the same thing. I want these features. And you have to come up with a way, how am I going to put this on our roadmap, and how I'm going to balance it. And it comes, part of that balancing act is our customer demand. So when you take a step back and you look at it just from a pure business perspective, did it make sense? And where did we put IPv6 in the prioritization? And let's look at the risk versus value. There's a lot of risk in implementing IPv6 natively. Because you have to touch everything. And you can't take down the business, right? That's why we're always doing our work in the middle of the night on weekends and holidays, because we wouldn't impact the business at that point. So when you start running a really large shop and you're running 7 by 24, business is really important, and don't take too kindly when you take them down. You take down an application server, you take down a whole center. They get really just a little upset about it. So if you look at it, and this is a great site, it's off the NIST site, and we look at IPv6 enabled DNS domains. And it's a pretty decent indicator of, who's doing what and how much work has been occurring on IPv6. I pulled this a couple weeks ago, and, you have about 1% that is active. that's about what I expect. The federal government's been under OMB mandates, so there's a lot of interest and activity in that area. They're constantly being reviewed to make sure that they're still IPv6 enabled. You've got some that are in progress. That's more than I actually thought that would be, that were in progress. And then you still have a whole lot of red, where DNS is not even thought about, quad A's and getting it stood up. Then you take the other side of it and look at IPv6 enabled services, and you got a whole lot of red. So we start looking at this balancing act again. What is our risk? What is our reward from business and technology, and where does it fit? So when you start looking at it, the most important thing, I think, from a business perspective, an application developer perspective, is you must have upper management support. And Microsoft has a lot of support from IPv6 in how important the technology is. We've had some stumbles getting it implemented within our infrastructure, but that's not because we don't have the support. We have a lot of support for it, and it's absolutely necessary. Because if you're going to centralize the deployment and be able to track it globally, you must have upper management support and backing to make sure that it's a success for you. So if you remember, one of the things that I said we didn't do so well with our original addressing plan. So we took a step back and we said, okay, we're going to start all over again. This time, we coordinated with all of the different groups within Microsoft. We sat down and we talked. Now, I will tell you, a year later, I'm still talking to groups about their addressing plan. I got about this much of the addressing plan sorted out, and I still got about this much left to go. So keep in mind that when you start working on it, if you haven't started on it, 1, you're going to do it 2 or 3 times. 2, you're probably going to fail a couple times, and that's okay. And 3, keep in mind that after all of that, you're still going to have to make changes. You're still going to tweak. So 6 months ago, when I started working on the addressing plan and working with the major properties and trying to pull this addressing plan together, we spent almost 9 months coming up with this much of the plan sorted out. Mind you, I still got this much to go. I've only talked to a couple major properties. I still got a whole lot to go. But it took me 9 months to get that part sorted out. I'm now a couple months down the road after everybody agreed, everybody signed off, we're all feeling really good. And now what's starting to pop up is the corner cases of, oh, you forgot this, or oh, wait, we decided to change this architecture. So now we have to go back and tweak it. That's a fact of life with the addressing plan. It's a living document. It's not going to change. But what we did do is we did come up with some standardization. And we talked about this yesterday. We came up with some standardization that said, this is our stake in the ground, so no matter how we organize it, this is what we're going to end up doing. /64 for a subnet. I think that's pretty best practice, pretty standard, right? You've got a /40 for a region. You've got a 48 for a site. My definition of a region and my definition of a site is going to be very different than somebody else's, and that's okay. You have to look at your businesses and try to decide what is our definition and what makes the most amount of sense. As part of doing that, you have to keep in mind all these other little pieces. How am I going to aggregate my routes? Who's talking to who? Where am I going to set up my ACLs? Right? I have Office over here. They don't want traffic coming in from Xbox. Xbox is over here. They don't want traffic coming in from Office. And that's okay. But you have to take that into account as you develop your plan. You have to think about these things. Where am I going to set up my ACLs? Who talks to who? How are we going to get it going? And how am I going to aggregate my routes? Now that becomes really important because when we started taking this in the lab and we started working on this, we looked at some of the memory available on some of our network gear. And this played a big part in our addressing plan. So in this example, we could store about 200,000 /24s. 24s, 26s, anything along with that. Great. Now we start factoring in IPv6. If we go to 100% IPv6, we can only store 77,000. There's not a 1-to-1 ratio, right? So you have to start looking at your balancing act and deciding how is that going to impact what I want to do and how I want to set up my addressing plan, how I'm going to aggregate this up, at what levels, how many tiers. That all plays a factor in it. But this also reiterates why testing is so important. You can't just go to training classes. You can't just listen. You can't just read books. You have to get your hands on it because every environment is going to be different. And I can set this up in a lab and you can go to a training course and you can do this in a training course and it all work nice and pretty. But when you take it and now apply your environment, your business requirements, it's going to be different. And you're going to want to look at it and see how it affects your environment. Training, labs, so important. So the other thing that we did is we began coordinating our effort for IPv6. Because again, you have to do that. Everybody can't do their own thing. We have to work together as a team, as a company. We're one big company. Let's coordinate everything. Let's make sure we all have the same plan. We all understand where it's being deployed, how it's being deployed. So if we have a customer need, we can say, oh yeah, that's no problem. And not have to go figure out, oh yeah, we have it here, but we don't have it here. So we took a step back and we're really working hard on coordinating all our business groups. And this is just from a purely, internal aspect. But everybody needs to do the same thing. Don't forget about all these other things, right? Your security cameras. And to give you an example, we had a project that was going on midstream right now to go update all of the conference rooms across the campus. We got a lot of conference rooms. We got a lot of buildings. So they're going through and upgrading all the conference rooms. Well, as we're talking about IPv6 and somebody just happens to get this email while we're in the middle of the conversation because they were having problems with one of the machines, and everybody went, uh-oh, everything was being deployed with IPv4. And we found some of it didn't even support IPv6. So when you're thinking about your IPv6, which probably should be now, you have to go back and look at everything that's in play. Look at it all and say, okay, does it all support IPv6? Can I put it out there already IPv6 enabled? So now we have to go back and we have to reevaluate some of what we're doing. It's going to require a second set of touches. It's going to require a whole lot more work. We've just doubled the work of what we were doing because that was not something that was thought of at the time. Your procurement process should have IPv6 as a requirement for purchase. It should be IPv6 enabled. Now, okay, vendors have a habit, IPv6 enabled checkbox. Now, whether it works or not, that might be a different story, but, at least you've asked the question, right? So make sure when you take a step back, look at it, and look at all these different pieces of what you're deploying, not just desktops, not just servers, not just network equipment. Applications. Okay, we're an application shop primarily. We have a lot of applications that have to support IPv6. We have to get on the roadmap for all of these applications. Again, it's kind of tied to customer demand, but we have to get on the roadmap. Outside of that, think about all the applications that are homegrown. You probably have written tools to help your monitoring. You've written tools to generate reports. You've written tools for other things that are all inside your company. They all have to be evaluated for IPv6. You want to start looking at what works, what doesn't, and get on the roadmap of how are we going to fix it. We're either going to dump it or we're going to have to go modify it and take it forward. So getting on the roadmap for these applications and getting the planning is so very important because, again, it's not something that's going to happen overnight. You got to plan ahead for these things. And you got to plan years ahead for these things in some cases, right? And of course, you got to keep beating the drum. IPv6 is important. IPv6 is important. We're not trying to break you. It's important. People laugh at me. So to give you some examples of work that we're doing inside from an enterprise side trying to get IPv6 working, we decided we had to come up with a goal. What's our goal? Besides the big company as a whole in getting IPv6, we need a smaller, more achievable goal, short-term goal. So one of the short-term goals is that we're going to set up one building that is IPv6 only. One building. That should be doable. All the desktops, all the operating systems are already dual stacked. I don't think I have to mention that they're all running Windows, do I? Okay. Just make sure. So they're already dual stacked, so we know that they can support IPv6. We can use NAT64. We have DNS64 already with direct access. So we have a lot of the building blocks to get IPv6 going. But before we decide to go to this whole building, then let's do a little pilot of a little group, right? We tend to, as IT people, we experiment on ourselves first before we go broader, because we experiment on our friends. So we pick a little group of like 10 people that are on the same floor, a couple admins, a couple managers that are friendly to the cause, and we turn them on to IPv6 only, just to see what works, what doesn't work. And then we can take a step back and figure out why it doesn't work. So what we did is we had IPv4 hardwired and we had IPv6 wireless. We had, here's my example, we had 2 laptops, exactly the same hardware, exactly the same operating system, exactly the same patch level. We flipped them, IPv4 to IPv6. One of them got an address immediately. Boom, bam, on the wire, working happily. The other one took 300 seconds before it got an address. Why? Okay, let's try this again. 300 seconds. What's the deal? What's the difference between the two? Checked everything. Operating system, checked patches, checked. Figured out that 300 seconds was the timer on the RA. Okay, we can adjust that. We can take it down to 5 seconds, gets pretty close to being real time, but that still doesn't answer my question. Why did one work and one of them take 300 seconds? We're still actually trying to figure this one out. We've got it narrowed down to the firmware on the NIC card. I can't tell you why yet, but we're still working on it. But what I does want to bring up is that when you're trying to do these tests, which again, testing's important, lab's important, when you're doing these tests, you have to think broader than just, it's the operating system. You have to look at the different elements of the operating system, because it may not be just the operating system. The other thing is, as we're troubleshooting some of these things, what's the first troubleshooting step that everybody says? Turn off IPv6. And I don't mean go in and disable, in the operating. I mean, we turn off the IPv6 wireless, then we go back to IPv4, and then we try to figure out, is it because of, when your first step in your troubleshooting is to turn off IPv6, yeah, okay, we got some education going. We got some education issues. But that brings up another really important point. When you're trying to deploy IPv6, you're going to have to re-educate from bottom up. You got to start with your help desk people. You got to work with the people that are deploying your systems in the field, all the way up to just, your network engineers. The whole span. Think about all the documentation that has to be updated, all the troubleshooting guides, all the SOPs, right? You just added a whole nother year for nothing other than documentation. And that's after you figure out what you have. So while we look at these applications or these operating systems and we try to figure out what's working and what's not, let's talk about a few more little things related to Microsoft clients. So we all know Slack. We all love Slack. Slack is great. I can set it up. I can get it up and running. I don't have to do anything else because it's up and running on the network, right? And don't forget that even with Slack, you can still use DHCP v6. You can still use your DHCP server to pass options to your Slack clients. And it actually makes a lot of sense to do that because now you can pass different things of how you want your clients to function on the network, and it's not quite so Wild West with your Slack. But if you enable Slack in your environment and you go look at it, our ever popular ipconfig/all, you will see that you now have 3 addresses. You have an IPv6 address, which is Slack. You have this famous temporary preferred IPv6 address, and you have a link local address. We all know what link local is. We all know what Slack is. And then we have the ever popular Microsoft temporary preferred. So why do we have this? Well, Slack, the idea behind Slack is you take the prefix, then you take the EU64, EUI64. EUI64 is based on the Mac. You take the Mac, slap it in the middle, flip it around, right? You could, if that is the address that you're always using, you could be traced back, right? It's a security concern. And I know people are laughing, Microsoft security, but I know, but it is a security concern. So what Microsoft did is they went with the idea of these temporary addresses it's not using EUI64, right? And the idea behind it is that it's a randomly generated IPv6 address. It is a specific timed value, so it's not there always. It's still using Slack in the sense that you've got this prefix, but the rest of it is all randomly generated. And after a valid lifetime, it regenerates it. So your temporary address is constantly changing. That sounds great. Just gave all the security people heart failure. Because how do you trace that? If it's constantly changing, how do you trace that? And that's the biggest thing about Slack that a lot of security folks will tell you is it may be great for a lab, but if I'm trying to trace somebody who's doing bad things on my network and the address is constantly changing, that just made it a big nightmare for me, right? So a lot of security folks are not a real huge fan of temporary addresses or even Slack for that reason. So now we have managed DHCP or DHCPv6, depending on how you want to call it. If you don't suppress the RA, so it's advertising a prefix, and you have the configured for managed DHCP, right? So you have the M bit, and you're still, doing all of that. You could actually end up with at least 4 addresses. 4. And guess what? They all work. All of them. And they all pass traffic. All of them. You see your security folks in the corner, they're all twitching. How do I deal with this? What do I do? What do I do? Right? Because I can't, how am I supposed to, I got a client, he's got 4 addresses. So, and the temporary one keeps changing on me. So if you go the route of doing managed DHCP and stateful DHCP, however you want to call it, make sure you think about these things. Turn off the RA prefix. If you turn that off, that will get rid of your addresses and you're down to 2. You're down to your link local and you're down to your managed DHCP. And I even added the nice little Cisco command down here for Cisco. I worked hard to find that one. Okay, so again, this is one reason why it's really important to get in a lab and test and play, because you want to know these things. You want to be able to solve these problems before they become problems on your network. Now, if I have 4 addresses on my network, which one is actually used? Well, that kind of depends, really. There is this nice little RFC that has all these beautiful rules that talk about how an address is used. Should start here, work my way down through here, and that gets me through all of, which address is going to be used at what point. But it can all change based on an application. An application may decide that, hey, I'm going to go with rule number 3 and totally forget rule number 1. I'm going to start here instead of here. It all depends on those application developers. Those dang application developers. Right? So again, you got to go back to getting on the roadmap. What are they doing? How are they doing it? Implementing IPv6 is not just a network issue. It crosses all boundaries. You have to look at everything. It's not just the network. So you have to work with the application developers and find out, especially if they're homegrown, how are they doing it? What are they doing with IPv6? How are they doing their addresses? How are they coming up with what they're going to use if there's multiple addresses on the wire? And And that brings me to the ever popular happy eyeballs. We all love happy eyeballs, right? Happy eyeballs. It's supposed to make life easier if you're dual stacked. Well, of course, Microsoft did it differently. We know. The premise behind why it was done differently is because happy eyeballs is application-based. Again, application-based. An application can choose how they're going to implement it. There's some guidelines. There's an RFC. But, how often do people ignore the RFCs and do what they want anyway? So Microsoft took a look at it and said, that seems a little short-sighted. Because it's application-based. We know we're going to have this period of time where we have this transition between 4 and 6. But eventually, we're going to all be IPv6 enabled. So I don't want to go that route. I want to come up with something that's probably a little longer term. And so they went with testing the IPv6, the NCSI. I always get that backwards. And so basically what happens is if you have a dual stacked environment, it will go off and it will do a test for IPv6 and see if it's functioning. Not is it configured just configured on the client. Is it actually functioning? Do I actually have traffic? Can I get from one point to another? Windows 8 does this test, and it checks for operationability of IPv6. Now, if it fails, and it comes back and it says, okay, yeah, you don't really have any good routes for IPv6, it doesn't stop IPv6 from working. It just demotes it. And so IPv4 becomes the preferred interface and the preferred IP address that's being used. Now, it'll go back and it'll test it again. It caches the information. It'll go back and test it. So it's not like it's stuck there forever. But it will do this. Now, if you happen to have an environment that is IPv6 inside only, you can still use IPv6. Again, it hasn't disabled it. If all you have is IPv6, it will use IPv6. Let's say you're in an isolated lab or something. It will work just fine. But in general, when you're going out from a dual stack, and again, the idea is that this is more a longer-term solution. I'm not just trying to fix what an application is doing. I'm trying from an operating system perspective to make it easier to deploy and not have such negative impact on the customer base. Now, one last thing I want to mention, because I think I've mentioned a couple times that you got to go fix your applications. You got to go look at your applications. There is a utility that is available with the SDK. It's called Check4. Check4 is not the end-all, be-all, but it helps. It's a utility that will actually step through a code base and try to highlight for you where you may or may not have issues as it relates to IPv6. And at least point you in a direction. It's not meant to fix it, not meant to solve all your problems, but it's just to assist you and help you in finding maybe where you might have to go change something. And it's part of your SDK. If you have SDK, you can get it. So I'll take questions. Understand, let's level set here. I'm not an application developer. I'm not allowed to talk about roadmaps. Okay?
Yeah, I had a question about the NCSI and why you guys went that direction instead of happy eyeballs.
Yeah.
Working a lot in the DoD and the federal government, there's a lot of closed networks out there. And is there any I guess, plans in the future for Microsoft to actually be able to edit the NCSI registry instead of trying to hack into it to change it? Reason why is because on the CIPRNet, obviously, there's no IPv6 NCSI web address that's out there and things like that, or on some other closed government networks and things like that. I've had to actually hack that registry thing instead of having to make it an easier configurable action. You know what I mean?
I haven't seen that, but I am more than willing to go follow up on that question and see if I can get some sort of answer. Oh, Ed, please. Come on, you promised to be nice.
No, I'm answering Jeremy. So all you have to do is actually publish the URL set that she had there and grab the text file off of Microsoft's site and just publish that in your DNS for that particular URL, and it will work internally. So that's actually how you do lab testing. So if you want to do lab testing, the URI that's utilized, the IPv6 MSFT NCSI.com. Yeah, but it's easier than doing a registry on every single host. It'll work for everyone.
You can set up a zone of that name only.
Yeah, and then as long as that's operationally reachable via the website for V6, you're all good.
It's not as pretty as what you like, but you know.
Yeah, but it works.
You said turn off the RA. I hope you meant turn off the A bit.
Advertisement.
Yes. Turn off the A bit on the RA.
Yes. Turn off the advertisement.
We'll turn off the auto config.
Yes.
Advertisement.
Yes.
Yeah.
I did.
Okay. Thank you.
Okay.
Thanks for your talk today. I know direct access or remote access is starting to emerge with IPv6 dependency, at least internally, as an application. Can you talk a little bit about what other applications might be moving towards IPv6 dependent functionality, if any?
No. No. But we could talk offline.
I realize you're focused mostly on the enterprise stuff, but the elephant in the room,
Yeah.
Skype.
I know. Skype. Yes, I know, Skype. All I can say is that there is support and guidance for Skype and IPv6. How's that?
Any word on Azure's as you're in this particular hole at the moment?
There is a site, and if you catch me afterward, I can point you to the feedback site for that environment where you can provide feedback on the importance and value of IPv6. And I would suggest that's a good conduit because there's already a IPv6 specific request in there to have more support, and customer feedback is very important, and I think would help in that whole prioritization. Am I not answering anything? Got to you?
As part of the Fed V6 working group, we've added V6 to FedRAMP. So to get FedRAMP certification.
So can you talk, let's talk about the enterprise side for Microsoft's challenges around V6. And can you talk a little bit about, given the size that Microsoft is, the campus deployment, things of that nature, and I know you guys tackled V6 very early on a dual stack environment, an ISOTAP environment. Is there any sort of guidance that Microsoft can give others about the transition from like the early ISOTAP to a dual stack environment, and then some of the challenges around the help desk, debug, troubleshooting, what sort of support and operation considerations they had to put in place in order to be able to help, very large organization, help them to understand how to deal with V6 operationally in their environment day to day?
Yeah, that's, even though every desktop is out there as dual stacked, I think that is one area that is still behind, is the training for the desktop support in supporting IPv6 and how do you troubleshoot IPv6. There's a few isolated labs on the enterprise side that are 100% IPv6 just from an application development standard. They have to be able to test IPv6 in a native environment if they're going to make it work. Right? So we do have those environments in place. There's been a little bit of work on trying to educate the help desk in how to troubleshoot it, but there's still a lot more to go, because even on the enterprise side, the prioritization and the working together aspect got lost for quite a long time. And the enterprise side had their own addressing plan, had their own IPv6 space, had their own ideas of how they were going to deploy it, versus the other side of the company, which had their own. And they pretty much worked independent of each other. And we're now starting to see where that's caused problems, and we have to come back together and work on it. And part of working on it is the support, and how are we going to support it, and how are we going to work together on it. The transitioning, there hasn't been a lot of challenges per se from transitioning from ISATAP to dual stack, because it hasn't been that big. You know, again, you had very isolated groups that are 100% native IPv6, and so they can take some pain points where your masses can't. Did I get there? Close? Yes, sir.
Hi, Tom from Infoblox.
Hi, Tom.
So I know we have a best current operational practices for help desks that's really sort of service provider oriented that just came out recently.
Yep.
It sounds like we need one for the enterprise side of the house, and I'm imagining that we're still early days with enterprise IPv6 adoption, but it's a good time to start establishing that framework and filling it out. And I think it ultimately we'll probably have a much larger document than what they have on the service provider side, because of all the gotchas and the things that you've described.
And I think it's really important for that, because I think it would help enterprises understand what it's really going to take.
Yeah. Are you interested in working on such a document?
Sure.
Yeah, right on. I'll talk to you about it. Okay.
Sure. Anybody else? Okay.